In this lecture, we will get an introduction to operating systems. Operating systems is one of the most important course in computer science, and it basically tells you about how the computer is managed, okay, how the whole system is managed, what are the things that are there in a computer, and how everything's work together. So in this introduction, we will just get a bird's eye view of all that is there in your computer. So we will learn about what operating system does, computer system organization, computer system architecture, what is the architecture of your computer, what is its organization. So a few important things are processes. There are processes in operating system: memory management, storage, security. So a lot of things are there. So we will look at them one by one. So we will get a very simple layman kind of understanding of what are all these. So like protection, distributed systems, computing, open source operating system, and so on. So objective of an operating system. So this lecture will provide you a grand tour of major operating system components. Then to provide basic computer system organization. So first, very important question, what is operating system? We are talking a lot about operating system. So what is an operating system? So your computer, so it's basically operating system is also a program. Like you write your C code and so on. So your computer operating system is a program that acts as intermediary between a user of a computer and the computer hardware. So your computer is basically, it consists of several hardware. It consists of your CPU, it consists of your memory, the RAM, hard disk. Then you have a lot of input output devices are also there. So we use all these to run some programs. So when you write some program, who allows, so these are the hardwares that basically solve your problem. But how it is done? So operating system is the device that helps you use all these hardwares, okay? So operating system, the goals are execute user programs and make solving your problems easier. So whatever programs, application programs are there, it helps them to execute. Execute means basically the CPU, so it will execute each line of your code, make the computer system more convenient to use. It allows so much abstraction it gives that you don't know, you just call, for example, printf, okay? In C you call printf and you say that OS, okay? So what happens, this is the system call, okay? So a user level function, and now what happens in turn, your OS, this will help to use your input output device, your monitor, to print something out there. And it also allows you to basically use all the hardwares efficiently, okay? So these are the functions of your CPU, of OS. So now let's try to see computer systems. So what is the structure? So how is your computer system organized or structured? So few important things are, so your computer system can be divided into 4 components, okay? So first is, of course, your computer is basically a hardware. So you have the CPU. CPU is the main horse which runs all your code, every instructions, everything is run by your CPU. Then you have memory. So there is a person, okay, he can think, he can execute something, but he needs to have memory, okay, where he can store something, okay? So if I have found a very big result, I can store it in the memory. Then you need to have input output devices. So one very important thing is your computer can be very much mapped to the humans, okay, human people. So how? So your CPU is basically the person, the brain, okay, which is working and it is executing something. Memory, so you have your memory where you store something. Input output devices, your sensory organs, eyes, ears, nose, so something like that, and mouth, so where from you get the input from eyes you see, and then output from mouth you speak something. So input output devices are also like that. Operating system, so what it does, it controls and coordinates the use of hardware among the applications. So let's say you are using a computer, okay, and you are playing some song, okay, so you are playing some song, you are also running some C code, a very long C code, okay, so everything is happening parallel. You are also browsing web, so many applications are running together, and now you can think all of them might be trying to use the input output device, keyboard, monitor, okay, and they might be trying to use the memory also. So how is it happening? Who is basically helping to manage all these, like the applications to use those resources? So it's the operating system which helps to allow which one to use the resources. Now, so this is basically the pictorial diagram that explains very clearly how these all things are getting done. Okay, so let's try to see. So you have lot of users here. Okay, so users are there. Then you have at the lowest level, you have the computer hardware. Okay, you have the computer hardware, CPU, input output device, memory. Okay, then you have the operating system. So it's kind of an interface that tells, okay, so which user will now use the CPU, which user will use the input output device, who will use the memory, and when, so that all of them are using it efficiently as well as fairly. So this is the work of operating system. Then you have the system applications and programs, okay, so which are running, and then you have the compiler. So this is an important introduction because you get an bird's eye view of everything. Compiler, assembler, editor, database system, all these are applications which are running and trying to solve their problems by using the hardware. And operating system is an intermediate level code which allows all of them to use these resources very efficiently. So this is the idea for operating system. Now, what operating system does? So again, this is very much like it allows you to share the resource utilization it tries to do, and so on. So let's try to, so it's a resource allocator. Okay, resources are there. CPU, let's say 3 people are trying to use the CPU. So there is only one CPU, let's say only one single core computer is there, user 1, user 2, user 3, all of them are trying to run their code. So OS is the person who decides which user will run now, which user will run after that, and so on, decides between conflicting requests. And OS is basically a control program, controls execution of programs to prevent errors and improper use of computer. So it also thinks and decides, okay, if someone is trying to utilize something, then it will give you some error or prevent the errors also. Okay, so this is there. Next, let's try to see, okay, what is operating system? So everything, so you get on a computer with, initially it has the operating system, the one program. Now we will look at what is the kernel. Kernel is something people become afraid when they hear initially. The one program running at all the times on the computer is the kernel. Everything else is either a system program which ships with the operating system or an application program. So kernel, what is a kernel program? So kernel is basically the very core of your computer. So this is the program that is the most core or basic program that allows handling CPU, input output devices, memory. So this core is always running, this kernel code. And then you have above that is the OS operating system code, then you have the system programs, then the application layer program. This is the system programs, operating system. Okay, so kernel program is the basic program that runs. Now let's try to see one very important question: how does the computer start? Okay, when the computer starts, so what happens? Operating system has not started yet. When you see, so what is there? How there is what is a code? Operating system is also a piece of code, which, okay, so but what happens is, who will start the operating system? So there typically we have a small piece of code typically stored in a random, so ROM or EEPROM, okay, and it is, so this is the one which loads the operating system code. So there a small piece of code is written in the read-only memory, and from there it knows that, okay, where is the code for operating system starting, and then CPU will start executing this code and bring up the operating system. For examples, in when you start the Windows 2000, Windows Vista, Windows 8 and so on, so what happens is they all will start and it will take some time. So basically from the ROM they see which part, what is the starting part of the code, then they will load the operating system into your memory and start executing, and loads operating system kernel and start executing the operating system. So this is the way computer starts. So I think this is there for our first lecture, okay, and then in the next lecture we will see about computer system organization. Okay, so our next lecture will be on computer system organization. So I hope you understand this. So thanks a lot.